What's up, Arc Junkies? Welcome back to another episode. This week, I'm thrilled to have Mark Winchester and Jesse Mccullum from Everlast Welders with me. Today, we dive into the nitty-gritty of welding aluminum, explore effective teaching techniques for welders, and discuss some of the advanced waveforms and functions of the new Typhoon model. Plus, we take a closer look at the new Red Saber laser welding, cutting, and cleaning system. We'll get right into it after a quick word from our supporters. Today's episode of the Arc Junkies Podcast is brought to you by Fronius USA. One of the greatest potential threats we face as welders is welding and cutting fumes and particulates. The best thing you can do to mitigate exposure is to eliminate contact with the fumes and particles with a fume extractor. Fronius has recently released their mobile fume extractor called the Exento. I've been using the Exento for a few months now, and it's been a great addition to my shop. The Exento is offered in a 120 volt and a 230 volt version as well, and it's super powerful. It has an impressive 9.5 foot reach from the base of the unit. It's easy to push around the shop, and replacing the filters is ridiculously easy. Fronius also has a high vac system as well that you can capture fumes right at the gun. Check out both systems at Fronius USA for more information by going to their website, fronius.com. We're also brought to you by CK Worldwide, the standard in TIG welding. CK Worldwide has been leading the charge in all things gas tungsten arc welding since 1967. That's over 5 decades of innovations. When it comes to any issue with TIG welding, CK Worldwide has your solution. They have a torch for every situation and application to include standard heads, flex heads, flex lock 360 rotating heads, which is my favorite, micro torches, pencil torches, and many more. In addition, CK offers gas saver kits, silicon nitride cups, which are tougher and more durable than the standard pink aluminum cups we're all familiar with using. Check out CK's products firsthand by going to ckworldwide.com and hitting the Find a Dealer tab to locate a distributor near you and find out why CK Worldwide is the standard in TIG welding. We're also brought to you by Outlaw Leather. We all know Outlaw makes some badass custom leather welding hoods, arm pads, bolt bags, rod pouches, and more. But Outlaw is also a one-stop shop for all things welding to include hand tools, layout tools, PPE, welding gloves, pipe fitting tools, ironworker tools, and much more. They also have a section on their website for student essentials if you're just getting started in the industry. Check out outlawleather.com and explore everything they have to offer. And if you need a custom hood, just shoot them an email, info@outlawleatherllc.com, and let them turn your concept into a reality. And as a special bonus for listeners of the Arc Junkies podcast, you can save 15% off on all in-stock handmade leather goods when you use Arc Junkies in the discount box at checkout. That's outlawleather.com. All right, you know what time it is. Fire up your machine, drop your hoods, and turn me up 5.
Thank you for downloading show number 324 of the Arc Junkies Podcast.
You're listening to the Arc Junkies Podcast, helping you make every weld better than your last with each episode. And now your host, Jason Becker.
Mark, Jesse, welcome back to the Arc Junkies Podcast. How y'all been?
Been doing good. It's been a minute, Becker.
It has been a minute. You were on in my early days.
Yeah, I think I was one of the first couple that you had on.
Then Mark was on there for a bit shortly after that. I was able to track him down.
Yeah, we did the FabTech.
FabTech Chicago last year. That was a good one. I took a deep dive into aluminum.
Yep. Always a good combo.
I should have never asked you that question, because as soon as I got back, the guy never wanted to do any more testing, and I was like, damn it, I really wanted to test this theory out and see if heating that aluminum plate up would solve the issue. But I did go through and I grabbed a couple plates and just heated them up with a Burns-matic torch, and you could literally see, all the moisture.
Yeah, there's a lot of people that say that it's just the moisture coming out of the air when you heat it up. But me and Jesse both have
that's a conversation that Mark and I have had a couple times, where when I was doing some aerospace testing, doing some D17.1 on 6061, we were having some really bad porosity issues, and we couldn't figure it out. I mean, we tried everything from Weldo chemical cleaner to remove the oxide layer, different cups, different gas flow settings, different tungsten, different prep, everything. And I actually ended up teaming up with Bob Moffett. And I ran down to Crawley one day with like, dude, I think I had like 75 test plates that I'd ran with all different, parameters and, all different variables. And the only thing that was consistent with removing porosity from 6061 was basically sweating out the material. That was the only thing that was consistent across the board.
Huh. Would you preheat it with? Or like what temperature wise?
Dude, it wasn't even a temperature. Like we didn't have like, I didn't put a temp stick or anything on it like that or a laser.
Okay.
It was literally just, it didn't matter if it was MAP, because we tried MAP gas and we tried like oxyacetylene setup. And as long as you put the flame to it and kind of just let that moisture like wick away, the plates wouldn't even have to be warm still. Like, I don't know, I probably did like 25 or 30 plates at once. So after like even, I don't know, 30 minutes, those plates were still, I had them all marked, how long it had been, because we were seeing like if we heat it up and sweat the moisture out, is 15 minutes too long? Is 30 minutes? Is an hour? Like, when does it start going bad again? And even like 30, 40 minutes out, it was still better than any of the other prep we did. It's there's a lot of people, they'll say it was just the condensation from the combustion that you're seeing, but I think there's more to it than that. But
no, it's a differentiation between the temperature of the base metal and I guess ambient temperature of the room.
Yeah.
Or, if you got moisture, from humidity or anything like that in there, especially because you're out in Kansas, I imagine you guys got pretty heavy duty moisture, humidity, and all that shit.
Yeah, we get the worst of everything. So yeah, our humidity, especially in the summertime, it can get pretty bad. So yeah, and that's of course when we were doing all of our testing was middle of July, so about the worst case scenario for us.
Yeah, it's hitting 100 degrees here today, and it's not even June yet. I'm dreading what July and August is going to look like. I'm moving to Alaska, man. Screw this.
So Mark just got snow last week.
Jeez, lucky.
Yeah.
Damn. So, hey, yeah. So I mentioned, I can't remember who I was talking to. I mentioned it a couple times, and I wanted to ask you just to get this squared away. You guys both prefer using 5356 over 4043, right?
Well, I guess I'll start with that because Jesse he uses 4043. So like where I used 5356 was in the marine industry. So it has higher corrosion resistance. It being a 5000 series, it's considered a hard wire versus the 4043 is a soft wire. But it has magnesium in it, which increases the corrosion resistance. So with the 4043, you have like silica base. So it doesn't have as good as corrosion resistance. And then that silica, you can't anodize. So a lot of the mil spec stuff I did all got hard black anodized.
So 4043 was out.
You had to have the correct filler. Yeah, it would turn gray. It went the actual filler metal won't hold the pigment of the anodize. So, but just recently in the last 5 years or so, I started using 5554. And where I learned about it is I was doing a chassis. Basically, it was an auto body shop. And they had a Corvette come in that had the aluminum chassis on it, rear-ended somebody. So they have a specific part on this chassis that's designed to fail in a rear end accident, so to speak. So literally I just cut out the plug welds and re-plug welded the new part of the chassis back on according to their spec. And that's the filler that they spec'd out. So that filler, the 5554, the one thing about it, it's very similar to 5356, and then it's very similar to 4043 in its fluidity and the way it flows out and everything. It's a lot like 4043, but it doesn't have a service temp like 5356.
Can't be used in an environment that exceeds 150.
5356 has a sustained service temp limit. So obviously anything. What was it, Jesse? Like 180 degrees or something like that.
Yeah, 53, 56 is a 150 degree cutoff for service life temp before it'll start cracking.
And then 55, 54 doesn't have that limit on the temperature, so you can use it for a lot more applications, and it also anodizes.
Yeah, and actually, like, so when I was at Pro Charger, that's pretty much all we used was 4043, and that's just the way it was. That's what we ordered. But once I started going out on my own and doing some of my own stuff, actually, I had learned about 55, 54 from Mark, and that's the only thing I use in my shop now. I keep some 4043 on hand if I'm doing some like 3003 or something like that, some lower quality aluminum. But or castings especially. But I pretty much use 55, 54 for everything now because it's as strong. I mean, the difference in strength between 55, 54 and 53, 56 is nominal. It's basically the same strength. It's got better ductility to it, better corrosion resistance. It flows in like 4043. So for me, switching from 4043 to 5554, if you put them side by side, I wouldn't be able to tell which was which. It flows in just like 4043, which is really nice.
And that's why I've always liked 4043 over 5356. I think it just seems to flow a little bit better because of that extra silicon in there, because that manganese is a little bit more dense, so it's a stiffer puddle. Especially if I'm running a spool gun. Like I love 4043. It doesn't feed for shit, but it runs really good. It's very smooth.
Yeah, and that's
actually. Have either of you tried the 4943?
So I've tried the 4943. We tried a couple boxes of it when I was at Pro Charger. I didn't like it quite as much, but then I've actually been using 4943 in spool guns lately, and for my aluminum MIG work, and I like it a lot better than 5356. The puddle definitely does flow better. It's a softer puddle. So I do like it for MIG work. I didn't like it for TIG so much.
Okay. I got to try some of this 5554 out now.
You can get it from Mark. Hit him up.
You got some?
Yeah, I'm a dealer, so I can get you whatever.
Filler metal dealer? Which company you repping?
I don't want to say.
I got you. Top secret squirrel
Top
shit.
Secret.
Okay. Yeah, I'll hit you up on the back end there.
Yeah, for sure.
Yeah, because we use a lot of when I teach the week-long comprehensive class, we get into TIG welding the last 2 days, and the second half of Friday is usually we get into aluminum. And I tell them, I was like, I prefer to run 4043. I said, but I've got people that are way better at aluminum TIG welding, such as, I name you two guys, and then Stephanie Hoffman and Dusty with Pacific Arc TIG welding. I'll name all y'all, and I said they prefer 5356, and they know more about welding aluminum than I do, so they're probably onto something. But like most welders, I've got an opinion, and I'm kind of stuck in that rut. I just like the way it flows, and that's what I always use. And I've never really had to anodize it. So, but if I do have to anodize something, I'll run 5356. But like, I'm still trying to figure out that aluminum stuff. That's probably the area that I'm not like the best in, just because it's completely different than welding anything else.
Yeah, it's that's where the whole black magic behind aluminum comes in. I think if you learn how to weld aluminum first, go into like stainless or mild steel, feels like child's play. Whereas if you come from if you go to mild steel or stainless first and try to go to aluminum, it kind of throws you for a loop.
Well, yeah, because like with aluminum, I like to do manual pulsing with aluminum, and with steel and stainless, I really don't have to do that. I mean, there's certain instances where I do, but with a lot of that, I just get the proper temp going with the foot pedal, and then just slow, steady travel speed, and just dab the filler, and boom, 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 and just rip it on down there. But if I try that with aluminum, you're carrying too much heat because of the travel speed. So I don't know. I just prefer like a manual pulse with the aluminum.
Yeah, the pulsing, it helps create like a rhythm and then fluidity in the puddle. It helps push it along. When like DC, you just literally point the tungsten, where you want it to go, and the puddle's going to go there, right? So That's kind of like where like people that learn on DC first, where they technically in a sense learn bad habits that don't directly translate over to welding on aluminum. So it's almost better to learn on aluminum, learn how to weld like that, and then go back to DC because the technique for aluminum, it translates better over to DC welding than it does.
Maybe I'll try that because I'm doing
if that
it does.
Makes sense.
I'm doing another week-long comprehensive next week, so I'll try that and I'll teach the aluminum up front and then switch over to steel and stainless the last.
Yeah, like DC, people have a tendency to try and lean the torch over so they can see. They want to be able to see. So when you teach, aluminum, you teach them to stand the torch up, and then they have to figure out how to see a different way, right? So I always tell people, don't worry about where the tungsten is. Don't worry about the center of the puddle. Just watch the very leading edge of the puddle. That's all you got to care about is that very leading edge. Don't care about anything else. And then once that muscle memory kind of develops, they're able to interpret, what's happening just based off a muscle memory rather than trying to rely on their eyes.
Hey, Becker, as an instructor, I know you had a long time in the industry, and I think Mark and I have kind of talked about this too. Like once you get so much experience in, you really start shutting your brain off while you're running. So like you're not thinking about, oh, I'm too hot, oh, I'm too cold, oh, the puddle's doing this. You just kind of develop that muscle memory.
Muscle memory.
Yeah, you just read the puddle. You don't even have to think about it. Your body just corrects it as you go along. And that's one of the things like with starting to teach welding classes, I've had to go back and think about like, oh, I'm not thinking about this while I'm doing it. So it's taking me a minute to wrap my head around how to explain like 90% of the stuff I do because I just do it. I don't think about it.
Yep, you're on autopilot.
So when you started instructing, how did you get around that, like to really start breaking it down?
So I practiced prior to the class starting. So I had full access to the lab. I didn't have a class yet because they were paying me as an adjunct to go in there and set the program up. So I had full access to the machines and everything. So I went in there and I was like, and I had to do this for every process, but I was like, okay, I need to break down what I'm doing step by step, Barney style. Like it's what they taught us in the military, the KISS method. Keep it short and simple, or keep it simple, stupid, whatever. So I would literally, we're going to start off on stick welding. So I would grab, I'd start at the very beginning. This is the electrode holder. This is the stick, or the electrode, put it in there in the, figure out exactly which segment of the jaws you're going to put it in. And then I would prop myself up and I'd stop and I'd analyze, okay, how's my body positioned? Because I have to explain this later. So I have to start, because like you said, you're on autopilot. So I just started doing, I would walk myself through what I was getting ready to do step by step and just kind of break it down and evaluate it as if I'm trying to explain that to somebody. Because a lot of times you don't realize how much people don't know. So you've got to break it down like super simple.
That's been
super, because I'm throwing out standard terms and definitions and they're like, huh? So you got to break it down step by step. It's like making a peanut butter and jelly sandwich. You ever heard of that analogy?
No. Mm-mm.
So there's like this thing that we had like a staff NCO from the Army explain it to us one time when I was up in Aberdeen, Maryland, learning how to weld. He's like, you're making a peanut butter and jelly sandwich, right? If you miss one step, you completely screw the whole thing up, right? So if you're trying to tell somebody how to make a peanut butter and jelly sandwich and you're like, okay, you grab the bread and, you smear the peanut butter on it and then you put jelly on the other side, and you never told them to take the bread out of the bag.
Oh, yeah.
Right. So you missed a couple of steps. So first thing, you're going to take the twisty tie and you're going to turn that counterclockwise 3 to 4 times before the twisty tie comes off. Then you're going to reach in and, grab 2 slices of bread. So you got to break it down. And if you skip a step, that's when a lot of the confusion comes in. So you really got to break down your technique step by step. And it might even help to record yourself, because like once that arc lights up, you're on autopilot. It's all subconscious at that point. Yeah. And you just weld. And then you're like, shit, I was supposed to be evaluating and breaking down everything. But like watch your work angle, your rod angle, all that stuff. Plus a lot of that, like I started doing tons of research when I got into education, because those books are going to tell them how to do it too. And then I would just take that information and relate that to something that, I've done in the past, like a past job, or I like to tell stories when I teach welding, because then people remember the stories. They don't necessarily remember the information you're trying to convey, but if they remember the story, they're like, oh yeah, this is why this is working. So it kind of gives them something to their memory to grab a hold of.
Yeah, that makes sense. And that's kind of the thing I've struggled with, doing the live streams. I've got, the people there to kind of ask questions. So I'll always like go back, like, oh, I didn't explain that, I'll go back. But yeah, the couple of classes I've done as like, warm-ups to opening up our school. That was the toughest point for me was, oh, you don't know how to put the tungsten in the torch. Like, oh, you don't know how to put you don't know how to put a gas lens in a torch. Oh, you don't know. Yeah. It was like, oh, I got to really start back from, you don't know anything. And that was really tough for me, especially making a run. I'm like, oh yeah, we're going along. I'm tapering off and okay, it's starting to keyhole. So I'm tapering on. Well, they don't know what a keyhole is. So It's been, got to focus a little bit more on the individual details, I guess. Then.
Yeah. Just break it down step by step. And it's going to come a lot more natural as you get into it, and you're going to start realizing things. And then as you're teaching, you're going to learn more about it. And then as you're watching somebody else do it, you're going to realize, you already know why you get certain discontinuities. You know what causes overlap, what's going to cause porosity. But when you can watch somebody do that, you're just going to start picking things up super quick. As soon as they're doing it, nope. Lean your torch a little bit more forward. Okay, nope. You're trying to hit that filler metal right there in the center of the puddle. You want to stick to the leading edge. Just in front, so you just kind of break it down that way.
Yeah.
And then a lot of times I do welding hands on because that's the way I was taught. I said, you mind if I hold your hands real quick? Yeah. Like literally hold your hands. And they're like, okay. I said, I want you to be able to feel what this feels like. Listen to what it sounds like. Look at what it looks like. You kind of break it down and get in touch with your feelings, essentially. So, because welding is, you get tactile feedback regardless of what process you're running. You're going to get some sort of tactile feedback, and it's all about a rhythm. And as soon as that rhythm's off, something's going wrong. If your arc length is too far out, if you're too close, contact tip to work distance, whatever process you're running, you'll get that tactile feedback. You want them to be able to feel that. And if you can feel that with them and then identify that, then the light bulb goes off. They're like, oh, okay, yeah, it's been doing that all morning and I didn't know what it was. Yeah, you're too far away.
Yeah, I think Mark and I, we've both talked about how we do lessons, and that's kind of how we both do it, is we'll just kind of grab someone's hands and show them like, this is how you do it.
Yep.
Sometimes you got to go there.
But that's the best way to do it, because welding it's a full contact sport, man. It's hands-on. It's all kinesthetic.
So one thing that I learned teaching was, not everyone is receptive the same way. So you kind of have to like feel out like how they tend to learn. Everyone kind of like understands stuff differently. So, like just like spending time to where we're, I'm just letting them run welds, and get comfortable. And then I, from afar, so to speak, I watch and kind of like see like, how their mannerisms are when they're holding the torch, and, how their body posture is and stuff like that, to see their comfortable level. Because once we get going, I literally rip into you. Like I'll pick apart, bad technique, and I'm like, don't get offended. Because I've actually had people shut down, like they're just like, well, I'm not doing that. And I'm like, well, you are. Like, here, I'll film it, like, they'll run about an inch of weld, and all of a sudden it's like a ladder. They start lifting up every time, they move, and the arc length keeps getting longer and longer and longer. And they're like, no, I'm not doing that. Like you're wrong. And I'm like, well, like here's the video. Filming yourself weld is a really good learning tool, because you get to see how your body posture is and like how your hands move and stuff like that. And a lot of people, once that hood drops, it's kind of like everything goes to shit.
Oh, real quick.
So,
but you're right. Everybody's got like a different learning style. And so, one person's going to learn completely different from somebody else. So you have to learn how to teach to those different learning styles too. I want to say there's a book, Alpha Dog by Mark Breslin. And he talks about that in his book, the different learning styles, and like from a leadership standpoint. So different personality types. everybody learns a little bit different. Somebody's going to get offended because you're picking apart their welds, whereas somebody else is like very inquisitive. They're like, please tell me what I'm doing wrong because I'm tired of struggling. Whereas somebody else is like, I'm doing the best I can. You're telling me that it's still not good enough? Well, yeah, not yet, but it's going to be. Like we're going to get there. And filming them is a great way to do that. I used to, like, I don't know how your lab is set up, but I would like kind of sneak into the student's booth while they're welding and video them, not like being a creeper, but I would film, like 10, 15 seconds or whatever their weld pass was. And I'd say, okay, here, I want you to see something. And I'd play the video back and say, okay, you see your posture right here. You see your arc length or your contact tip to work distance or travel angle or travel speed. So this right here, what you're doing here is what caused this on your plate. And then you go and show them the weld. And, they eventually learn, they start building that muscle memory as well.
Yeah, even filming, like I had a student, like everything from my perspective looking through the hood, it looked proper. I'm like, dude, like I don't know what exactly you're doing different than what I'm doing. Like from looking through the lens in my hood, looked like he was doing everything right. But I filmed him and then I walked away and then I went and sat down and I watched it and I watched his hands. So something that I just couldn't see looking through a lens, I was able to see, in a video. So, it's a really good tool, if you're not like directly seeing it, like you can replay it over and over and over and look at different things. But what he was doing is the way he was introducing the filler, he started side filling like halfway through. And like when you're looking at the puddle, like you don't actually like see him side filling like through like a helmet and a lens. But in the video, I could see him feed the filler head on, right on the leading edge of the puddle. And then he kind of like rotated his hand and started feeding from the side. So that it was actually like behind the shielding gas almost, the flow of direction. You always want the filler and the flow of direction. So he was almost started filling behind it.
Yeah.
So
so I reached out to this guy because Stephanie had one of them in her shop and it was for students to like hold their cell phones, so they could film themselves while they're welding and stuff.
Yeah.
But it's he's on Instagram. It's called frogpod_army. And he makes like these little magnetic, it's kind of like a tree frog. I'm guessing that's where he got the name from, but it's like 3 neodymium magnets, but it's got a cell phone holder on it. And like when you buy it, it comes with, attachments for a GoPro, cell phones, whatever. But because the way my boots are set up, they can put those little frog pods right there on the, like the positioning bar that I have set up, or right on the bottle of shielding gas or on the side of the machine. And they actually, a lot of them film themselves welding because, they're capturing the moment. But then you can also play that back and you can watch yourself. Cause, how many times you don't get to see yourself under the hood, but if you can take a 30-second video of you ripping out a 4 or 6 inch weld and then go back and hit the playback button and say, oh yeah, now I can see exactly where I'm screwing up or what's causing the issue. You get instant feedback.
Yeah, I've had a couple times when one thing I like to do when I'm teaching someone is have them run an edge weld on like some 090 aluminum, just because it really makes you focus on how you add your filler rod, your torch angle, your amperage control. It amplifies everything. So if anything's off, it shows it immediately. And of course, I show them a couple times and I've got the machine set to 100 amps. And I'm running 90 amps the whole way across the top of this edge, but I'm going super fast and I'm dabbing in filler. And he goes to do it, and it's melting down. He's sticking filler all over the place. And we go back and look, and I recorded it. Well, you can see the settings on the machine. He was only running like 55, 60 amps. He'd jump up, and then he'd immediately come right back down as soon as he got the arc. So he's sitting there preheating the material, and it's too hot. Like, he's trying to add filler and the material's already too hot. And I kept telling him, like, yeah, you need to get into the pedal more. Oh, I'm wide open. I'm wide open. The video says otherwise.
Turns out that was a lie.
We'll tell you what, though. Speaking of filming people weld, I had Eliza Vita Watson in to our little demo area here in Kansas City a couple months ago. And, TIG welding, you can tell how stable somebody is by how much their arc voltage varies, because that's your arc length. So if you're running whatever, let's just throw in numbers at 150 amps, and your voltage is 18.3. If you come down at all, your voltage is going to go down 18.2, 18.1, 18. You go up, it's going to go up, of course. And I'm telling you, I saw her run like a 3-minute weld, and I don't think she moved like a nanometer. It was when she was locked in at a voltage, that was it. Like one of the most impressive things welding wise I've seen live is just how absolutely precise that woman is. It was truly impressive. And I wouldn't have noticed it except for going back and watching the video and editing it. You see it like, oh wow, she is just rock solid stable.
That's most females are, man. They've got that attention to detail and that stability, hand-eye coordination. I don't know. That's I Am Girl Welder, right?
Yeah.
On Instagram, yeah. I was having a conversation with a guy today. I went and he had to do 3 weld certification tests for the company that he was working with, and I hooked my multimeter up to his machine, and he's starting to ask questions. He's like, "Hey, man, what are you doing?" And I was like, "Well, a lot of times machines can vary based off of what you're getting at the arc versus what's on the display. I got to make sure that you're within the operating amperage of the welding procedure specification that you're testing to." And so we got on the subject of arc length, and because he was like, how's that work? And I was like, well, it's a clamp on multimeter, and I said, I could check your amperage here, and I was kind of going through the settings and everything, and I said, but I can also check your voltage. And I said, now here's the cool thing: if I'm checking your voltage, I don't even have to see you weld to tell you whether or not you're holding a tight enough arc length.
Yeah.
Because if you're 18 volts to 24 volts, down to 16, up to 32, if your voltage is jumping all over the place, that tells me that your arc length is not consistent throughout the entire piece.
Yeah, exactly.
But if you're maintaining, if you're plus or minus half a volt, plus or minus a volt, maybe even a volt and a half, you're maintaining a pretty consistent arc length throughout the entire plate or throughout the entire weld. He's like, man, that's incredible. I was like, yeah, you don't even have to see the weld being performed. Like I can tell you how well you're doing because that's a constant current process.
Yeah. No, 100%.
Same thing with MIG welding. If you're on MIG welding and I'm checking your voltage across that, or I could check your amperage and I can tell you. That's why a lot of people, they want to do the whip and pause. Well, if you're looking at on a voltmeter, you might be going 160, 200, 140, 210. If you're whipping and pausing, because you're all over the place, you're not maintaining a consistent contact tip to work distance. And because that's a constant voltage process, your amperage is now scrambling all over the place.
Yeah, that's actually when Mark and I are doing tech service calls and it's some sort of a MIG issue. That's a lot of times one of the things we'll want to see is show us a video of the front of the machine while you're welding. And yeah, if it's set to 19 volts and 250 inches per minute, and then they arc up and it goes down to 16 and it's up to 23, it's like, well, it's not the machine. It's the operator,
the pilot, not the plane.
Yeah, it's not the welder. It's the welder.
Yeah, exactly. That's got to be. I bet you guys get some pretty interesting phone calls.
Oh yes.
we don't have to dive into that.
Yeah, we don't have to dive into that. But yeah,
Jesse and Mark's customer service. How can we help you?
Yeah, let's keep it clean
what's
here.
Yeah.
Oh yeah.
Let's keep it clean.
No, it's we get that. I tell you what's fun with doing the tech support is it's fun actually problem solving for somebody. Someone calls in and they're pissed off and they think, their machine's broken, and then you spend 5 or 10 minutes with them and you can, obviously we're talking on the phone. You can't see the light in their eye, but you can hear it in their voice when
you can hear it in the voice.
Oh yeah. Like, oh my God, this, oh yeah, that's it. That was it. I can't believe it. That was it. And like, that's why they pay us the big bucks.
That's gotta be fun.
Yeah. It's always the torch in the wrong terminal every time. Oh, really? That's wrong? Well, yeah, try it now. It'll be a different machine completely.
It's going to work now.
Yeah.
It's going to work this time. That was the thing and you guys will appreciate this, is like the more you learn about welding, the better welder you're going to be. But like the more about the fundamentals that you learn, the better off you're going to be when it comes to welding, especially like troubleshooting, like things immediately. You're like, oh yeah, I'm set up for electrode positive when I should be running, DCEN. And so you just reach over there, switch it over. But I mean, having that fundamental understanding. Because when I went through welding school, like my instructor told me, you're going to weld aluminum on AC, and AC starts with A, and aluminum starts with A. So that's why you're going to run it that way. And then when you run steel and stainless, you're going to run on straight polarity because all three of those start with an S. But now that I understand what that electrical circuit's actually doing and how electricity flows, and the melting point of pure tungsten, and the amount of amperage that's applied, or the amount of heat that's applied on the DC negative side and the DC positive side, it's like, oh, that makes sense why it works. So once you understand the why of something, you become much better at what you're doing.
I think, especially, Mark and I were really key on developing the new Everlast Typhoon, and I think in the process of that, like, we both learned a lot about how welders are built and why they're built a certain way, and why things, the way the circuits work in the welder. And I mean, I think I'm speaking for Mark too, but it made me understand what I was doing even more, having been on the other side of the curtain and, kind of behind the scenes working on the internals of a machine like that.
What's that like, as far, because like I usually don't open my welding machines up. I mean, when I was a kid, I used to take apart all kinds of shit, and I some of it I could figure out how to put it back together, some of it I couldn't. So I've always been a little leery about like taking the can off the exterior of my welding machine and start poking around with shit.
I mean, it's once you start understanding, like, okay, the power comes in, it goes through this transformer, it goes through the input inverter board. The power goes through a soft start relay. It goes through the capacitors. It goes to the secondary inverter board. That sends it up to a power control board. It goes to the your main board. Then it goes back to the high frequency board, flyback transformer. Then it comes out. So real fast. When you start working through each piece of that, when you are having an issue with a machine, like if I'm having a weld issue, I know how the Everlast machines are built, but you can better understand why the welder is doing something and where the source of the problem is. And I think that's like one thing Mark and I deal with a lot is people don't understand how a welder is built. And so they'll have an issue like porosity, for example, especially on aluminum. We get a lot of calls in the tech service line about that. Oh, my machine's causing porosity. Like, no, your machine is not causing porosity because it can't cause porosity. You have a gas issue, and that's caused a lot of we'll say heated conversations.
Yeah, it's almost impossible to prove it, right? That they have contaminated gas, right? So, the only variable is to have them get another bottle of gas, see if it gets better. Jesse had a customer that went through 5 bottles of bad gas before he got
I bet I know where he was shopping.
And the guy was so mad. We changed out the torch, we changed out the solenoid, we changed out the regulator. Basically anything that had gas flowing through it, we changed on the machine. It's still same problem. Then after that 6th bottle, the guy,
yeah, I mean,
like, I'm sorry, Jesse.
this guy, we were getting to the point where like we were like cussing at each other. And I was like, dude, I'm telling you, I was like, I will Venmo you $200 if you promise to go get a bottle of gas from a different supplier. I was like, I will give you the money just to get rid of this headache. And he was like, okay, I'll do it. And then sure enough, 9:00 in the morning next day, hey man, like, yeah, what's up? Yeah, it was bad gas.
That's got to be a hard one to troubleshoot over the phone, because like you can't detect a leak over the phone, and then you're kind of relying on them to make sure that they're actually doing what you're telling them and doing it correctly. Especially for a lot of novice welders that are out there, like, okay, check this, check that. Like sometimes they don't even know what they're looking at, let alone what they're looking for.
Oh yeah. I mean, yeah, 100%. I mean, I actually did a short video. I think we posted it on our YouTube channel. We were doing some filming, and I actually had a machine come in from a customer that we had ran through like 2 or 3 times, like settings, try this. It won't weld. It won't strike an arc. It won't, okay. We swapped machines with him, had him send it to me. I unboxed it. Settings were way off from what I had told him to set it at. Machine welds fine. I've used it for 2 weld classes. I think I even filmed 2 YouTube videos with it welds perfect. But yeah, I guess Mark and I always relying on people to actually try what we're telling them. And sometimes I think that's kind of like I was asking you earlier about instruction, which I think I can kind of take that back with me to the tech service department, is maybe they're not actually understanding what I'm asking, which I think that is a lot of the problem we run into.
And a lot of times they're super confident that they're doing it the right way. It's I think I've told this,
especially the ones that say they've been welding for 20
they've been
years.
doing it wrong for 2 decades.
As soon as someone tells me they've been welding for 20 years, I'm like, yeah, you're for sure doing it wrong.
Exactly.
Oh God, you got me.
Don't die on us.
Oh, you got me.
That's everybody's go-to, though. As soon as you tell them they're not doing something right, they're like, I've been doing it this way for 20 years. Well, congratulations. You've been wrong for 2 decades.
That's why I'm excited for the laser welders, so we can start fresh, because nobody's been doing it for 20, 30 years.
Exactly. So, yes, tell me about this new Everlast Red Saber laser system you guys have.
They're incredible. I've been working on the project now a little over a year. Mark's come on a little bit after me, but I was really against him. Like, I thought we were wasting our time, thought it was a waste of money. And then I got that first prototype unit in, and I made about 3 welds with it. It's the future. I mean, you might as well get used to it. It's the future of welding. If you're not actively trying to learn about laser welding right now, you're going to be behind in 2 or 3 years. I mean, they're insane. It's absolutely mind blowing, Jason. It's how fast they are, how clean they are, how easy it is to set up. It's for thin material right now. It's going to be the hot ticket.
Yeah, because I was checking them out because I think I was talking to Austin with Weld.com.
Yeah.
He had mentioned that you guys were coming out with a laser system, and so I started like at the time it wasn't on the website, but you've since come out with the system. I mean, you've got a couple different models on the Everlast website, and like I've been wanting to play with one of these things for a while now.
Yeah, we're trying to get you one. We're trying to get you one down there. They keep selling out too fast is the problem. Like we're selling them faster than anything, any projection we ever had. We're 30x what we thought we were going to be selling in lasers.
Well, it's like a freaking Tesla. Everybody wants one. It's the future.
Yeah.
But like, because I've seen them, and I've always been somewhat apprehensive of like, what's, how thick can I weld with this? What's it going to replace? How much better is it actually? But the ones on the website, I think they're all pretty much right around 1/4 of an inch, which is like, that's where, short circuit MIG welding lives. So, and nobody wants to break away from short circuit MIG welding. The problem with short circuit MIG welding is it's prone to lack of fusion. And I think the laser's going to change that.
Yeah, the laser is definitely not prone to lack of fusion. That's that's for sure. But yeah, I would say you're right there. Anything under like 5/16 laser, yeah, laser. Especially if it's mild steel or stainless, it's definitely laser. That's
and you guys can do steel, stainless, aluminum, pretty much any weldable materials, right?
Yeah, any weldable material you can laser. And this is one thing that I've been kind of talking about with some other aftermarket companies. Like we were down at the GATA trade show convention in San Antonio a couple weeks ago, and we were partnered right up next to Victory filler metals. And we were talking about lasers. Well, one of the things right now where the industry's really behind is, do you know anybody that makes a titanium spool of MIG wire?
Not off the top of my head.
Yeah, or like Hastelloy or Inconil or magnesium. Like nobody MIG welds magnesium, but you can now laser it. But nobody makes a spool of wire. So the industry.
I'm sure it wouldn't. It wouldn't be a big ask for them to do it because they're already taken. Because MIG wire is the same thing as TIG wire.
Yeah, it's just
so. Instead of just run it down a couple more diameters, smaller, and instead of cutting it at 36-inch lengths, wrap it onto a 1 pound spool, 10 pound spool, or a 33 pounder.
And that's what we were talking to him about, is making up some sample spools so we can. There's none of that. There's none of that audio or video out there of a laser doing titanium or doing Hastelloy or doing magnesium. That it's not out there, and so that's one thing we want to start getting into, is really seeing how far we can push it.
I would imagine it would do really good on titanium because your travel speed's so much faster and your heat input, just based off the fact you're using a laser, is so much less. You wouldn't, I would venture to say, because I don't know this to be fact because I've not messed around with a laser yet, but I would venture to say your heat input is going to be much lower. So you don't need the additional trailing gas and all that other shit that goes along with it.
No, and that's something we haven't, I haven't got there yet, but when I do, that's kind of my thinking, that we might not have to have as much of a trailing shield because you're moving so fast and the bead is so concentrated. But yeah, it's that'll be in the next couple weeks. I'll be doing that.
Okay. Now, like, as I said, I know jack shit about lasers, so I'm going to ask a lot of dumb questions that are probably, yeah, I mean, there's no such thing as dumb questions, just dumb people. So I'm going to ask some dumb people questions, because I'm the dumb person in this situation. With the laser welding, like, I've always heard of like CO2 lasers and stuff like that. Now, because you're doing steel, stainless, aluminum, do you have to use like an argon shielding gas, or are you getting away with CO2, or do you need a shielding gas at all?
So you can use nitrogen, or you can use argon for welding, and it's the same for the cutting. So our machine's a weld, cut, and clean. So for the cleaning and cutting side, you can use compressed air, or you can use nitrogen. So yeah, but for welding, you're using argon or nitrogen.
Okay. And do you have different size cups available, or is like just pretty much standard?
So the tip sizes are all based upon, or the tip types are all based upon what type of weld joint you're doing, whether it's a butt weld, fillet weld, outside corner, cleaning. It's all a different tip on how it rests on material. There are some like do all tips that they're kind of good for all different types of joints, but it's kind of a you kind of select what you're doing, and then you set the gun up for that.
Okay.
It's
pretty impressive.
One of the and we haven't got Mark on the laser yet, but I'm trying to figure out to either get him out and let him work with me for a couple days on it. But it's a totally different process. I mean, you take everything you know about welding and you throw it away and you start from scratch. It's so yeah, don't take any preconceived like, oh, this is how you do this, because it's going to be wrong.
It's not.
Yeah, it's not.
All right, ladies and gents, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by Everlast Welders. Everlast is still offering their bundle packs right now. So if you've been waiting for a sign to buy a new welder, this is it. They have MIG welders bundled with spool guns so you can get into that aluminum welding game. TIG machines with included carts and torch upgrades. Plasma units with included mechanized heads. Now is the time to save big on your next machine purchase. So don't wait. Head on over to everlastwelders.com and select the best deal for you and your current welding needs. And as always, if you buy any machine that comes with a stock foot pedal, be sure to use Arc Junkies in the comments section at checkout to get that free Nova foot pedal and TIG torch upgrade. Everlast Welders. Weld mean, weld green. Now let's get back to the show. No, I've been very interested for a while now, because like I've said, I've seen these things all over, not necessarily the Everlast version, but I've seen laser welding. Like, we've all seen the videos on weld porn and Instagram and like all throughout of these different laser systems. Yeah. And it's like, okay, cool. You stuck some metal together. Like, I want to test that shit. Like, I want to do some fillet weld breaks. I want to do some macros. I want to cut and bend all this stuff. Regular, guided bend tests. Like, I want to see what this thing's actually capable of, because I know it's a completely different weld profile as well.
Yeah,
you got more weld on the inside than you do on the outside, essentially.
Yeah, and that's one of the other areas where the industry's kind of behind where the technology is, because there's not a whole lot of code written for lasers, because it's all your throat thickness and your weld size. That all goes out the window. That all goes out the window with the laser.
Well, because it's like a deep, kind of like running MIG with 100% argon. It's like a narrow, like a finger-like profile.
Yeah, so like, I mean, I'm sure you've TIG welded 1/8" mild steel before. Your bead's what,
A couple of times.
Yeah, your bead's, about 3/16 of an inch wide, or ish. With the laser, I can get under an 1/8" wide bead and get full penetration on 1/8" material. A no gap butt weld, no bevel. So it's crazy. I mean, it's just stuff that you don't, as a welder, when I go to look at that, I'm like, this shouldn't work. And then sure enough, it does.
Now, what's the thickest material you've done on it so far? Like the one that you got in your shop?
The 1500 watt, the thickest I've done is 1/8" so far. I've got some thicker material coming in, but that's what it's rated for. It's rated for 1/8" material.
And then I noticed they've got different cooling systems on it. So you got like air cooled, you got water cooled.
Yeah. So technically, the water cooled's an internal refrigeration. So it actually has a mini AC unit inside the laser box. So you've got an air cooled box that has like 6 fans blowing air across all your electronics. The refrigeration unit, actually everything's refrigerated. So it's meant for like a 12-hour, 100% output, 12-hour continuous run.
Oh, geez.
So yeah,
and nobody's going to do that.
No, nobody's ever. I mean, unless you got a really nice robot that has no changeover time. But yeah.
Yeah, no, it's not going to consistently run for over 12 hours.
So yeah, that's what I'm saying. Like, you're not going to do that with any other machine, as far as a MIG or a TIG machine. Even on a cobot, you're not going to do that.
No. I want to look into it because I want to say that I think AWS is already developing codes and standards for robotics, but I don't know that they're doing anything for lasers.
Exactly. Yeah, I'm starting to get my foot in that door too, to start working more with the AWS. So you'll probably be seeing a lot more of me here pretty soon, Becker.
Hell yeah. Well, because I mean, the technology's changing faster than the codes. It's very similar to a textbook. Like by the time you write all the information for a regular textbook on any subject and you get it published, you're 10 years behind.
Oh yeah. I mean, it's the same way.
I'm sure codes and standards are going to be the same way.
What welder did you start welding on when you first started your career, Mark? I mean,
geez, probably old Syncrowave.
Yeah, it's a 400-pound. Yeah,
from you get the 70s.
A Syncrowave 350 from the early 2000s was like a 400-pound machine, and now you get the same output out of a lunchbox. So the technology,
it's got 60 dials on the front of it.
So I mean, yeah, the pace, the way that the pace of the welding industry is changing. I don't think. I mean, it's hard for me to keep up, and that's our job. I mean, like I said, even I'm a little bit further ahead on the lasers than Mark, just because I've got one to use. But it's, I mean, even for me keeping up, it's hard. I mean, it's hard to keep up with how fast the technology's moving now.
Yeah, it's moving at rapid pace now. And now they're incorporating AI into robots, which is freaking nuts when you think about it.
We need to clone Winchester as an AI bot.
There you go. They could probably do that, man. Get him into ChatGPT.
Oh man.
No, that's super slick. I mean, you've got a bunch of different versions available. So now with the filler metal, it's obviously the same. Is it like the same type of filler metal you would use for like steel? So you're using like a 70S6 or like a 308 for stainless or like a 4043 for aluminum?
Yeah, that's a nice thing for shops that are going to be looking at doing laser production and they're already doing MIG. There's no changeover in your filler material. It's all the same as MIG.
Is it the same diameter and everything?
So that's where it depends too, because we've got dual wire feeders available for the lasers, so you can run like 035 wires that I've been running on 1/8", but you can run up to 062. So you can run two 062, spools. So you can be pumping in basically an 1/8" of wire size. So you can get some pretty crazy thick wire for high deposition.
So you can actually do like twin twin feeding at the same, like simultaneous.
Yeah, and it'll pulse. It'll pulse the wire as well.
Holy shit. Yeah, I mean, you never see that in any of the videos. You just see the two little prongs come down, touch the joint, and then weld, and they just pull it down the joint, and that's it. You don't really get to see how the wires actually fed into it. I mean, it looks like it's just the laser doing the work.
Yeah, and some of it is, but yeah, it's as we get a little bit more experienced myself with the laser, I'm going to start showing some better. We've got some videos in the bank showing the setup of it. That's a lot more detailed than the live streams I've done. But yeah, it's I think it's going to blow a lot of people away.
Now, how, like out of the box, how hard is it to set up a laser?
15 minutes.
Because you said it's completely different than a welding machine. I mean, yeah, average welding machines 15, 20 minutes to get it all set up, and not including putting the cord cap on. But you said it's nothing like welding. So I mean, where do you start?
Basically, yeah, wired up. I mean, you just plug it in. I mean, you got to have your safety, your PPE stuff, of course, which is a little bit different than standard welding. Wearing your laser rated goggles. But other than that, it's turn it on. The machine's got a bunch of built-in presets. So if you want to fuse weld, I mean, it's literally hook a gas line up, turn it on, and you can weld. I mean, it's maybe 15, 20 minutes. So I think but from the first time I turned the machine on to making my first mild steel weld was maybe, and this is my first mild steel weld period with the laser, was maybe 20 minutes.
Oh, damn, that's not bad at all. And
when you use my third weld, I was getting full pin across a 7-inch coupon. I mean, that's how that's how easy it is.
And I would imagine it's very easy to see because you're just using like red tinted glasses, right?
So for the wavelength that we use, there'll be typically a dark green. So it's a 1080 Newton meter wavelength. So it'll be a dark green, but that's semantics at this point.
kind of like the old school. But I mean, like the clarity is a lot better than looking through a welding hood.
Yes and no. There's that's one thing where the industry's behind too. So there's it's basically like looking through like a shade 6 or shade 7 welding lens with those goggles. So it's not like super clear. Because it is actually, I mean, the laser itself, it'll burn your eyes out without you even knowing it's on. But the actual reaction to the metal it's still bright. I mean, it's still as bright as a weld. So it's not as bright, but it's close.
Okay. Now let's talk about safety for a minute, because that seems like to be a big area when it comes to operating laser welders and stuff like that. What are some of the things we have to consider? How do we not cut through the table or weld through the table, or like how do you control if the part's 1/8 inch thick but the material or the machine's capable of welding up to 1/4 inch material? How are you not welding your coupon to the table? How are you not if you're making a cut, once you cut through that coupon or that piece, keep moving and accidentally go through your foot or your leg or anything like that?
A lot of that's due to focal length. So the focal length isn't that far outside of the gun to where it's going to blow something up. So yeah, if you're welding and you're getting full pin and the laser's going through the joint, it's maybe 6 or 7 inches away. Like if you're welding out like an open joint or something like that, it's maybe only 6 or 7 inches where the laser's actually like, it could still catch something on fire. The cleaning, unless you there's some trickery to make things more dangerous than they are. So there's that aspect of the laser, but that's not to be discussed.
Offline.
Yeah, that's we can talk about that later.
Yeah. Yeah, because that was my biggest thing. I was talking to a guy at the, it's funny you mentioned Victory, because they were just at the open house for Robert's Oxygen, my local gas supplier. And so I went out there to their open house. One of the companies there, they had a laser welder, but they weren't demoing it. But he said they were messing around with it in the shop. Or I don't know if it was him or it was one of his clients. And they're like, well, I wonder what this does to flesh. And so they took a turkey breast. I see your eyes just got really big. They took a turkey breast and put it on the table and just like hit the laser, and it literally sliced right through it.
Yeah.
Like
No, there was
like one of Mark's briskets.
dude. The some of the people like talking about lasers on. We've had a couple ads come up, and it really makes you realize that nobody knows what they're talking about with a laser. Because they as soon as you said that flesh, I was like, oh god, I hope he did not. I hope somebody did not put their hand in front of that thing, because yeah, you're gonna lose a finger.
Cut it and carterize it in one shot.
You got to treat it like a loaded handgun, because it is. I mean, it really kind of is. And as far as like the safety and respect in it, that's how you need to think about holding a laser welding gun, is that it's a loaded handgun.
Yep, don't put the new guy on it, right?
Not until they're officially trained by a laser safety officer, according to the FDA. Noted.
Oh, so that's a new occupation now.
Yeah, laser safety officer is a new title that the FDA has invented for the industry.
Damn. Well, at least they got that right.
That's questionable too.
Yeah. What's the training consist of? It's a 30-minute online course.
Yeah, paying a third party a couple grand to tell you not to point it at people.
Damn. So is the PPE any different? I mean, you mentioned that instead of using a hood, you're going to wear a set of goggles. I mean, are there specific gloves that you have to wear, or any other additional PPE or things you got to consider?
No, that's basically it. The eye protection is the main concern. Everything else is standard. Just blocking light from touching bare skin. Other than the goggles, everything else is the same.
I gotcha. Now, tell me about the cleaning, because that shit looks really cool to be able to like take off mill scale and rust and all that stuff. Like how well does it actually work?
It takes off powder coat faster than anything you've ever seen. I actually want Mark to to try it on some of his powder coated valve covers, because it pulls powder coat off so fast. It's ridiculous. The cleaning side with the laser is for rust and powder coat. I mean, that was the big thing I was geeked out on. And that's been the main thing when I'm talking to people about lasers. Like, they're like, oh yeah, I want to buy a laser. Okay, what do you want to do with it? I want to clean rust or powder coat. Like, that's all they care about. So it's that side of it's really fun. It's also mind blowing how fast it will remove material.
I would imagine it'd be pretty satisfying too to just sit there and clean material all day with that.
I send Mark videos all the time of me just giggling like an idiot. Like, watch this.
Yep.
Watch me burn this off.
Well, going from a grinder to something where it's like completely, effortless, and you pull a trigger and point and just kind of move the gun up and down. It's literally reverse painting.
Take the first time you used a plasma cutter and times it by about 50. And that's what you're like, oh, it's like having
this is cool.
Yeah. It's like having I always tell people when they're buying a plasma, yeah, it's like holding the power of God in your hand in a torch, because everything's cuttable now. And that's kind of how that laser was on the cleaning side. It's like, oh, like I've got way too much power now.
Now, will it take off mill scale too?
Oh yeah. Yeah. Mill scale, powder coat, it'll take varnish off of wood. I was burning my I don't know if we need to talk about this, but I was burning my concrete in my warehouse the other day because it's got a bunch of adhesive on it from the previous company putting down carpet. And so I was walking around just giggling like a little schoolgirl, burning off adhesive off the concrete.
Jeez.
Yeah, I mean it's
that's got to be a lot better than running a grinder.
Oh yeah. Oh yeah. No, that's why I want.
Now,
go ahead.
Now, how wide of a section can you clean at one time?
So if you're using the 800 millimeter focal length lens, you're cleaning about 8 inches wide.
Holy shit!
Yeah.
And you can adjust that.
Yes, you can
based off the whatever tip size you put on there.
You base it off of your focal lens. So we have different focal length lenses that'll either narrow or widen out that laser beam, and it's also, how far away you are from the material is how far, is how wide that beam is. But yeah, it's all based on your focal length lens.
Damn. How close do you have to be with it?
With the 800, like 3 foot away.
Holy shit.
Yeah. That's what I'm saying. And if like with the 150 lens, you're like maybe 8-9 inches. Well, I'll call it a foot. You're like a foot away. But then you're only cleaning like a 3-inch wide path.
Dude, that's what I need to clean coupons for all the classes that I'm running.
I can text you a video here in a second of me cleaning a 3-inch wide coupon in about 3 seconds. I did it.
Jeez, yeah, no, I definitely got to get a hold of one of these things.
Yeah, no, it's it'll, like I said, it'll blow your mind.
Now, how bad are like the vapors or the fumes that it's putting off? I mean, like, what are the health considerations with that?
Equally as bad, or you're burning so much more stuff off. I'd say it's probably worse than your regular welding, because you're actually, especially on the cleaning side, because you're literally vaporizing powder coat or rust. So it's having a good respirator or a fume extractor is definitely a big thing to think about.
That makes sense. 'Cause I was just wondering, because like you're literally vaporizing it, so it makes sense. I mean, it's got to go somewhere.
Yeah, it goes right in your lungs. Yeah, it goes right in your lungs.
Yeah, but it's also got to like be really good as far as like cleanliness in the shop and everything, because you're not launching grinding dust all over the place and huffing that shit in every time you walk through it.
Yeah, you're just putting black floaties in the air. I mean, it's still the same. It's just you're putting black floaties in the air. You're not having.
Yeah, but if you got like a fume extractor and set it up on the top of that, it suck all that shit up.
Exactly. Yeah, you're not having sparks fly 20, 30 feet off a grinder, but yeah, it's just putting floaties in the air. So yeah, if you have a good fume extractor, it'd be a lot cleaner than grinding for sure.
Now, does it make any noise?
Yeah, it sounds like something off a sci-fi movie. I mean, that's what it sounds like.
Star Wars.
Yeah, it's not quite the pew pew, but it's like a whop. Like you go to put on the cleaning side, and it kind of spooks you at first, because you're like, oh God, like what is?
Is it gonna blow up?
Yeah, no, it has a very distinct it's its own sound. It sounds like a laser cleaning. There's not a word for it yet.
Okay. Is it pretty like? Is it loud? I mean, you got to wear hearing protection, or
no, it's just no. If I mean, it's not even. It's not any louder than welding on AC at 120 hertz. It's quieter than that, but it's got its own laser sound to it.
Okay. No, this definitely looks like cool new technology. Now, so I've heard that you can't do pipe with it, or you can't go around objects. So like if you wanted to build a roll cage or something like that, you're probably better off just TIG welding it out. Or is there a way to go around rounded objects with it?
I would say roll cages are out of the question at the moment. The gun's not quite compact enough, but I mean, if you can MIG weld it, you can laser it for the most part. It's not quite.
So you should be able to do a roll cage then.
Yeah, I mean, if you're dropping, if you can drop the main hoop down enough to get on the top sides, if you can drop it down enough, then yeah, there's some of the places like, on a main hoop right up against the B pillar that are always really tight. Those are always really tight. Or doing like the A pillar bars where the door bars meet. That's always a really, really tight joint. Even with TIG, those are sometimes really difficult. So someplace like that, laser, you're not going to be able to do it all, but you'd be able to do a majority. I think 75% of a roll cage you could do with a laser.
Really? Yeah, because I know there's the other company, I guess Light Weld or whatever, they said they can't do go around pipes and tubes and stuff just yet with it.
I haven't had that problem.
Well, maybe they're not welders.
Yeah,
so.
maybe I need to. I'm available for rent, I guess.
Consulting. There you go. Pimp yourself out.
No, but
that
was like the second thing I did with the laser welding was I did some 3-inch 065 stainless tubing, because I was like, turbo kits, exhaust, this is perfect. So that was like the second thing I tried. If you can put it in a positioner, you can laser weld it. So, I mean, there's that.
Now, Mark, you got any thoughts on like switching over from TIG welding aluminum to do all the custom pieces that you do and switch over and start doing them with a laser?
For aesthetics purposes,
I was going to say,
probably
like
not.
that, the welds you put down on there, I mean, that kind of sets the piece off. So if you're going to do it with a laser, it's probably going to look completely different.
Yeah, the laser, it produces smooth looking welds versus like a nice bead profile that kind of like brings that aesthetic on my parts. So like if I was like mass producing them, I really didn't care about the aesthetics of the weld, probably the laser would be the way to go.
Yeah.
For speed and reduced heat input. I mean, it'd probably help out a lot with distortion and stuff like that.
Now, what about like, have you tried cleaning aluminum with it? Does it take off like aluminum oxide?
Yeah, it does take off oxide, especially if it's a heavy oxide. If it's like brand new material, it's not as noticeable. But heavy oxide, like a piece that's been sitting out in the, out in the weather for a couple months, it gets that like chalky oxide on it. It'll burn that off too.
There you go, Mark. You could use it for prepping up all your aluminum before you go to weld on it.
I actually wouldn't mind doing it to remove powder coat, because now, like if I have a mistake during powder coat, I have to chemically strip the powder coat off, and it takes time, and then it's toxic and it smells horrible. And doing it with the laser, Jesse said I could probably do a cover in like a minute.
Yeah.
Or less, rather than an hour.
Yeah, it seems like there's a lot of benefits to it, because it'll cut, clean, weld. I mean, it's like everything all in one.
Yeah, I've got a guy right now that he runs a mobile service truck, and he does a lot of he mainly does like semi-truck, like trailer and frame repair on the side of the road. And he's using one mobile to clean up track, like cracks in semi-truck and trailer frames. That's what he wanted it for. He's like, man, some of this stuff, he's like, I grind it out, but there's still a whole bunch of junk all the way around the weld joint. And he goes, can I just use the laser to scan it and burn the paint off the frame after I'm done grooving it out? I was like, yeah, that's easy. So he's like, yeah, if it saves me having to, grind powder coat or some kind of industrial, automotive coating for an hour in order to clean it up, he goes, it's worth it. So he's got a little,
I can see that.
He's got a little 750 watt unit on his service truck now.
I had one of the students that took my class. We did this class for a group called Ladies on the Fly, and they came in just to do a weekend MIG welding class. And one of the ladies, she restores the old Volkswagen buses, and she bought a laser from, I guess, some company out in China. She got it on Amazon, but it shipped out of China or whatever. It was like $17,000, but it'll cut, weld, and clean as well. So that's what she uses, to restore all these old Volkswagens, because she can go in there and clean all the shit off and, make small cuts, and everything's very, very precise. And then it's thin sheet metal. So she just, puts that welding tip on there and, welds it all back together. She says it's freaking awesome.
Yeah. And that's actually one of the things I want to do with our unit. I've got a 62 F100 that's a cab on chassis. So it's got the wrong bed to match the cab. And I've got a 64 bed that it's a long bed. My truck's a short bed, of course, but I want to use the laser to clean the bed up, cut it, and then re-weld the bed back together and then put it on my 62. And that's one of the long-term projects I want to do with the laser, just to showcase it. Because I think for auto body shops, especially, the laser is going to be the ticket.
Now, is it pretty easy to run a bunch of tack welds with it?
Yeah, it's all in the settings. You can set it to a continuous or a tack spot mode. At that point, it's just like a MIG welder as far as the settings go.
Because I could see a laser replacing TIG and MIG all in one shot.
Yeah. Eventually, yes. Especially on, like, right now on thin materials, 100%. Like, if you're welding under 3/16 material, it's a pretty good chance that you could be saving a lot of money by using a laser.
So sheet metal shops, scenic shops, anything like that.
Yeah. Yeah, especially sheet metal, like food grade stuff, like food prep counters, sinks, like the restaurant sink, stuff like that. Yeah, those shops should be using a laser. There's not even a question about it, they should be using a laser.
Now, how easy is it to burn through stuff? Like, have you tested some stuff out and you're like, oh shit, because like TIG, if you're just learning, aluminum TIG or something, you can blow a hole pretty quick, or the same thing with MIG. Have you had to run into the same situation with running a laser?
It's the same way. Whereas if your wattage is much higher than your material thickness requires, like if you've got 065, that requires about 700 watts. If you're set at 1500, you're going to blow a hole in it. Yeah.
So now, is there a chart to like on the side of the machine that tells you like use this many watts for this much material thickness, or is there like a formula? Because TIG welding, MIG welding, stick welding is like roughly 1 amp per thousand of material thickness. Is there like a kilowatt equation for the material that you're welding on?
So the nice thing is it's all built into the programming of the machine, so you can basically tell it what you're welding, and it has a program pretty much built for it already. It's like I said, the technology is so much further ahead than your typical MIG or TIG machine. It's ready for beginners. That's how good it is. You just
got to get a laser safety officer.
Exactly. Yeah, that's basically it. But the machine comes up with a handheld touchscreen like remote, like a big LCD panel that you can set with like right next to you, and it's got like 15 or 20 different programs on it that are for different material thicknesses and joint types. So it's pretty much set up, ready to go. It's like it's like welding for dummies, really.
Now, is there like a safety on it? Because you said it's like a loaded gun. Is there? Do you have to take a safety off before you pull the trigger and start welding on it, or like if you're gonna swap tips out or something like that? Is there any danger of if I want to go from a cleaning tip over to a welding tip? I'm sure we've all had our foot on the foot pedal while we're swapping out our consumables or taking the tungsten out, and you zap yourself. Is there safety in place so that doesn't happen while you're swapping tips or anything?
So there are some different safety features built in. You can disable the laser beam on the remote panel. So if you want to swap something out real quick, you can disable it's a one button click to disable it. You can also set up the gun to be a single or a double trigger pull. So if you've got a double trigger pull, it's pretty hard to accidentally fire the laser. The single pull, it's not hard to accidentally burn something, which I've done already by mistake. So it
wasn't yourself though.
No,
so
it wasn't
good.
myself. It was my foam flooring.
Ooh.
But there's a door interlock, there's a keypad interlock, there's a key interlock. So there's three levels of don't mess with this built into it. So unless you know what you're doing, it's kind of hard to accidentally fire the machine off.
So if I had this at home or around a group of students or something, I could literally key lock it out,
Yep.
like with a physical key.
Yep, you can
turn it off and.
Yep, you could actually still have power to the machine, and then take the key off, and then there is no way that laser can be turned on.
Okay.
So you could lock the key up. You could keypad interlock it, so you could have the laser on running, and you can keypad interlock it to where you have to have the pin code to get into it. So there's that too. So yeah, it's there's a lot of safety features built into them.
That's pretty slick. Yeah, I didn't realize there was that much safety built into it. But obviously, for obvious reasons, you need that.
Yeah, it's like I said, it's a total different, it's a total different process. So there's a lot of different, safety features and functions of the machine that we're just not used to, as typical normal welders, so to speak.
Yeah. Now, who do you see like most of the companies or most of the sales from these machines? Are these like smaller shops or home hobbyists, or like what do you have any like data on the demographics that are buying this?
It's people who have money, because I've got everybody from, I literally had a guy buy a machine that's just a DIY guy in his garage that wants one because he can, and then I sold one to a motorcycle shop out in California. They do a lot of high-end performance motorcycle exhaust. but it's like one-off custom stuff. And then I've got a guy flying in from Indiana next week that, that he runs like a $75 million a year electric motor rebuilding company. And they want to use the laser to remove coatings off the outside of electric motors when they rebuild them. So it's kind of that's what really surprised us is we thought, oh, we'll order 10 units and we'll probably have them 4 or 5 months. And then we ordered 10 units and we had them like 2 days. And then we ordered 25 units and we had them like 2 weeks. So yeah, the sales of it have been much higher than what we thought they were going to be.
I could see that. I mean, because it's the latest and greatest. A lot of people want to be an early adopter, or they've got problems and like this is the solution they've been looking for.
Yeah, and our price point obviously helps that when we're a quarter of the price from the other competitors. That helps out a lot, and we have a better warranty. And when you call tech support, you instantly talk to a human. That helps too. That has been the main thing. I've had a couple people just say they had a laser, like, oh yeah, I've got a laser. They call tech support and they're like, yeah, I've got a laser. I go, okay, what's your name? And like, oh, okay, I don't have you as a customer. Like, oh, I just wanted to see if I could talk to a person. Like, oh, okay, well, here I am.
What do you want to know?
Yeah, what do you want to know? So yeah,
what's the warranty on it?
5 years. It's the same as all of our other MIG and TIG units. So we're doing the same exact warranty, 5 years, parts and labor. First 3 years, we cover shipping to and from a repair facility if needed. And then it's parts and labor the last 2 years. So it's same exact warranty. The machines are built in a similar fashion where they're easy to service for the customer. So that's that's kind of been a keynote for our machines in the past is that we let our customers service their machines and get them up and running faster, and it's no different with the lasers.
Have you had any issues with them so far?
I've actually had one call. So we've had them out now it's about 3 months now. We've had them out. I had one call with one issue, and it was because they dropped the gun and the focal lens was out of adjustment. Other than that, yeah, I think Mark actually took a call from a guy that they're running them hard and heavy all day, every day for the last couple months and hasn't had a single hiccup.
Now, as far as like consumables and stuff, what parts wear out rather quick? I mean, you think like, TIG welding, you got obviously your tungsten, your cups. Same thing with MIG welding. You got your nozzles, your contact tips, drive rolls. Like, are there any consumables on here that you kind of want to stock up on, or
the
wear
main
out
thing
rather
is
quick, or are these pretty long life?
The only thing really is the protective lenses and the focal lenses. That's it. And even, the focal lens isn't. You're talking a couple weeks on a focal lens. The protective lenses, they're meant to keep debris from coming back at the focal lens. So that protective lens, you might swap one out. I don't know, every day you might swap one out, and it's kind of like swapping out like a contact tip at that point. You don't swap them out as often as a contact tip, but it's kind of the same idea.
Okay. They relatively cheap, or
yeah, they're
like a high dollar item.
Yeah, they're a couple bucks each. They're a little bit more expensive. Contact tips like 50 cents, $1. I think the protective lenses are like $2, $3, something like that. So they're not too bad. No, the focal lenses, they're like $70, $80. They're a little bit expensive, but you also don't go through one very often. So, and I've been running my laser, we'll call it 10, 15 hours a week doing demos, and I'm on my original focal lens still.
Oh, that's not bad at all.
Yeah, that's been like almost 3.5 months.
Yeah. Now, are you guys going to be bringing this down to, or I would imagine Everlast is going to be at Fab Tech in Orlando, right?
Oh, just you wait. We've got so many things in store for you.
You bringing a laser with you?
Are we bringing a laser? Yeah, we're bringing a laser. We're going to have like 3 welding booths set up with lasers, but we're working on a bunch of stuff behind the scenes. That's what's been really fun bringing I was really honored to come on full time with Everlast. I was a longtime customer. when I had the chance to bring someone else on board, Mark was my first choice. He's about the only other person I really look up to and respect what they say. When Mark says it, I take it as basically as the Bible. So when I had a chance to bring someone else on, Mark was my first choice. So yeah, it's we're working on some really cool stuff that I think it's really going to surprise some people coming up.
No, that's cool. I can't wait to see it.
I can't wait to show it to you. We just can't talk about it. We just can't talk about it right now.
Yeah, I know. Yeah, no, that makes sense. No, you guys had a badass booth last year at FabTech, and I got to hang out and chat with you for a little bit, Jesse. And then I think right after that, Mark and I went and did a podcast, but I didn't get to see much of the show at all the past couple of years. So I think this year, even though it's going to be in Orlando, I'm going to try and not pigeonhole myself to a bunch of commitments. So I've got some stuff with AWS that I'm going to do. I think we're doing a podcast per day. While I'm there, we're going to do like a panel, or not like a panel discussion, but like a live podcast in front of a live studio audience once per day.
Oh, nice.
But aside from that, I want to go check out the shop floor. Like I want to go see some of the cool stuff and play with it. Like you guys released the Typhoon last year, the year before that in Atlanta, and I didn't get to play with it then. And then in Chicago, I didn't get to play with it, and it's damn it. So, I want to go weld. I want to go play on the shop floor. So
yeah, and that's
I'm going to try and stay low key this year.
The Typhoon is pretty much mine and Mark's little baby. That's our little brainchild there. So yeah, you've got to get on one of those. I think. I mean, you got Mark Winchester helping design a machine. What more can you ask for?
Yeah, exactly. Now, Mark, is that the primary machine you've been running lately? Is the Typhoon for all the stuff you've been cranking out?
Yeah, I've been running it for the last 2 years. Basically, since me and Jesse got the first prototype versions from the factory, and I've been running them ever since. So, I mean, what's really impressive is like, being able to fine tune, precisely, which, in years past, these settings and stuff like that, like, sure, you can tune to a certain extent, but you're always at the mercy of, like, let's say like a 3/32 tungsten, like the amperage rating on that, like typically like 230 amps, maybe 250 amps, even on a really good machine. That's about what you're going to get out of it. So with the Typhoon, we have an amplitude adjustment, which the amplitude is based on a percentage of the electropositive. So we can fine tune the heat input in the tungsten. So I actually was welding some 0.400 6061 to an 1/8 inch fillet, and I was like, I'm just going to leave the 3/32 tungsten there and just see like how far I can push it, because I can fine tune it. I was at 320 amps, and that tungsten did not disappear. So it took it, and it's all because of that ability to fine tune that heat input in the tungsten. So, that's impressive. And then being able to mix match like the waveforms on EN and EP, that really helps like fine tune depending on joint fit up and material thickness and stuff like that. You can fine tune that arc stability and the fluidity in the puddle and, per application. When before you just had one waveform, that you got to choose. And sure, that was nice, but taking it a step further of the arc control and stability,
So
pretty impressive.
You can adjust the waveform on the DC positive side and have a separate one on DC negative? Holy shit.
Yeah. Yeah, so you can have a triangle wave on the positive, and then a square wave on the negative, whatever, however you want to mix match them. So we have 5 waveforms now.
That's going to really help with point geometry on the DC positive side if you're just hitting that high end for just a split second.
Yes, I mean you can. Yeah, you tailor your waveform, and then you can adjust the amplitude on the positive side. So not only can you only hit your peak for a short amount of time, but you can lower where the peak is, in relation to your electronegative amperage as well. So it's extremely powerful tool.
I didn't know you could run 2 waveforms at the same time.
Yeah, we're actually getting ready to release a DC dual pulse on pulse as well. So that's coming to the Typhoons here real soon. I've actually got the programming to test that, and I'm going to start testing it here in the next day or two. So you'll actually run 2 DC pulse waveforms layered on top of each other.
Now, what's the benefit of doing that?
So typically when you go down low on amperage, that's kind of when the arc becomes unstable on DC. So if you're doing like thin stainless and stuff like that, so you can actually turn up the pulse to a high speed pulse, like 30 pulses per second and more, so to speak. And it stabilizes the arc to where it down low on amperage. It's almost like pinpoint accuracy. So having that high speed pulse, you have the arc stability, and then we're going to have an ability to have a low speed pulse so you can create a bead profile as well. So you can actually have that arc stability and have a low speed pulse so you can have like bead profile.
Now I got to learn way more about TIG than I wanted to.
See, Becker, I was just enjoying the look on your face while he was talking about that.
I was like, holy shit. Just when you think you've got something like...
and then
just
you
when
can
you
change
think you
the
got something
waveforms
like
on the pulse too.
you know something, here comes Mark with all his freaking wisdom and like these newfangled black magic shit.
Yeah, we've even got the...
Because I've never seen that on any other platform.
Fronius has it, and Fronius has it. They've had it for a while, but that's pretty much it. So, I mean, that's kind of the point with the Typhoon, though. When Mark and I were designing that machine, was we wanted to come in at the top of the market and be a real player, and that's kind of I think people are going to see us establishing ourselves there more and more as time goes on.
And that's something are you bringing that out to FabTech also?
Oh yeah. That'll be available on production machines probably within the next 2 to 3 months, and we'll also have it available as a retrofit to pre-existing Typhoon. So it'll come standard probably like midsummer, but we'll also offer it as a retro upgrade on the programming to pre-existing Typhoon customers.
Oh, slick. So you can just do an upgrade.
Yep. It'll just be like a program, like basically a mainboard reflash. It's like a 10-minute ordeal. So yeah, it's super, super fast, super easy.
That's the great thing about welding machines nowadays. You just get download and upgrade.
Wait till you see what we're working on.
I can't, damn it. So, I mean, I'm going to have to. I don't have any other choice.
Yeah, we've got some really cool things we're working on to in that regard as well. So there's I think on one hand, technology it kind of gets annoying, but on the other hand, when you start seeing it used in applications like this, it really starts making things a lot more convenient.
Now you really get to weld nerd out on shit too.
Oh yeah, I mean that's like, if Mark and I aren't weld nerding out, we're moto nerding out. that's about our two topics is either welding or some kind of motocross or supercross. Yeah, that's pretty much all I care about either.
Really all I care
and
about.
Smoking meats.
Has Mark ever sent you some of his beef jerky?
Yep. Good
he sent me some 2 years ago.
Yeah. We need some more of that. I was gonna say, you haven't made some for a while. We need some more.
I need to
beef
make
jerky.
some again.
A minute.
Well,
shit.
meat prices got out of control for a minute
8
there.
years.
Mark sent me the first batch one time, and I was like, dude, if you don't want to weld anymore, you could probably make some pretty good money making beef jerky.
Yeah, no shit, right? Yeah, he sent me some that had like what was it? Habanero pepper.
Yeah, that one's good.
Yeah. No, I gotta fire mine up.
Yeah,
that's the problem. So like, because I'll do the same thing here. Is I'll make some and like oh man, this is gonna last for a while, and then I get up the next day and it's all gone. Man, the wife, the kids, they plow through it.
Nope,
it's gone. You can't keep it in the house. A blessing and a curse.
Yeah, it's always fun. Yeah, and the thing is I like to share. So
I did a brisket one year, and I turned around and I should have started sampling. So like now I know better. Is like as I'm cutting it up for everybody else, I'm setting my portion aside and sampling as I cut. Because I think it was the first year that I made it. Like I sliced it all up, and I turned around and I set it on the table. And then I was over at the counter, and I'm like pulling the pork, and I'm getting that set up, and I set it over there, and I made redneck egg rolls that have pulled pork in them, and they're wrapped up with coleslaw and all kinds of stuff, and then you deep fry it a little bit. And by the time I got everything put out, I was like, all right, time to make me a plate. And all the brisket was gone. I was like, you gotta be shitting me. Oh, dude, I was pissed. So like now I know better. As I'm cutting it, like I build my plate as I'm setting the table.
Yeah, we need a bigger brisket next time.
Yeah, I know. I think it was like a 14-pound brisket.
Me and my neighbor have been getting those gold Wagyus from Snake River Farms.
Yeah, I still got that website saved on my phone.
I'll tell you, that's a game changer right there. That American Wagyu. Oh man,
I got to give that a shot.
Best brisket I've ever made, hands down.
So I just want to go out to Mark's house so I can eat like a king for a couple days. It's like we joke all the time, like we're kind of like the same person, but we're always like on the same food schedule. It seems like I eat pizza, he eats pizza, but I'm fixing like frozen pizza, and Mark's making homemade brisket.
Yep.
Just amazing pizza.
Make a brisket pizza. It takes me like 14 hours to make.
Yeah.
Yep. When you leave here, you're gonna leave wounded and probably up a belt hole or two on your.
Oh, so
yeah. When you guys come down here, I'll have to cook something up.
I was just asking, how far away are you from the convention center when we get down there?
I think it's probably, depending on traffic, obviously, but like maybe 20, 30 minutes.
Oh, that's not bad.
So I think I'm going to open up the school probably because like the last day of Fab Tech is usually half day.
Yeah.
So I'm probably just going to run back to the school after that and open it up for everybody to be able to come down and check it out and whatnot.
Nice. Yeah, I'm going to be down. I think I'm coming down like almost a week early, obviously, to set up and everything. And I think...
oh, yeah, you got to be there for a while.
Yeah, I'm going to be there for I think 11 or 12 days total. But yeah.
Orlando's much better than Chicago or Atlanta. You'll have a good time.
I don't think we could have had a worse experience in Chicago. Nobody warned me how bad Chicago was.
I've never had to load in or load out, so I could only freaking imagine.
Yeah, Chicago's not fun. Atlanta wasn't bad. Chicago, I could care less if we ever go back to Chicago Fab Tech.
Didn't they steal a bunch of your stuff, like the workers there?
That was Atlanta. Yeah, that was Atlanta. We got like half of our stuff stolen in Atlanta that first night. So that was
damn.
Yeah, we ended up spending 2 days running around replacing everything. It ended up being like, I don't know, like $1,500 worth of stuff that we got stolen out of the booth overnight.
What were they taking?
All of our grinders, flap disc, welding hoods, welding jackets, gloves, tools. I mean, just like everything. We had a bunch of power tools to put carts and stuff together that we had locked up, and they got into everything. So yeah, we lost a whole bunch of stuff at Atlanta Fab Tech.
Oh, that sucks.
Yeah.
Yeah, because I remember Chicago. I was working downstairs because that's where I had that booth at, Mark, or that room, and that's where I was doing my podcasting. Well, I had to run back up topside to get some stickers out of the AWS booth because we were doing arcs and ales that night. And so I come up the stairs, and I had to go over to the AWS booth. Well, I had to walk outside of the little roped off area to go get the stickers. And as I tried to come back in, the lady's like, security was like tight, man. She's like, where are you going? I was like, I'm renting a room downstairs. I had to run up here and get stickers. And like, she didn't want to hear it. She's like, you can't go back down there. And I'm like, all my stuff is down. Like, ma'am, I'll be back in like 5. You can go with me. I'll be back in 5 minutes. Look, I'm working with AWS. They're one of the main sponsors for this event. And she just didn't want to hear it. And finally, she's like, I'm watching. I'm counting on my watch. Like, you got 5 minutes. And I was like, yes, ma'am. She's like, I don't need you running around here, stealing people's stuff while the show's closed. I was like, that's not me. I literally came up here for a couple of stickers for an event. Now I got to go get my gear so I can run back to the hotel because I'm hosting that event. But yeah, like, Chicago was pretty tight, man. You could, once that show closed, you're not getting in and out of those ropes unless you got a vendor access pass or whatever.
Yeah,
and even then, I think they're following you around.
Man, they even stole our candy bars at Atlanta. We had a bunch of candy bars. They even stole our candy bars, man.
Damn, you can't trust nobody.
No, can't trust nobody. It was a really good.
I don't think Orlando will be like that. You'll have a good experience down in Orlando. I'm almost guaranteed.
No, I'm excited to get down there. Yeah, being close to, especially being close to where you're based. We've got our other sales guy Norm. He's based down there, so we've got a bunch of stuff we want to do while we're down that way too. It'll be a lot of fun.
Oh, Norm's down here?
Yeah, where is he at? Is it it's not Fort Lauderdale. I think
Fort Myers?
No, I'd have to look. He's just like an hour. He's like an hour south east of Orlando.
Okay.
Like, just because I know his
probably like Titusville area.
Yeah, I think his daughter lives in Orlando, so he's up there all the time.
Okay. Yeah, that was the Todd Clauser, the camera guy for Weld.com. I guess that was like Norm was his mentor.
Yeah. Oh yeah. Have you ever met Norm?
Yeah.
Oh, okay, nice.
Norm's a couple of times.
Awesome.
He's a good dude.
Norm's awesome. I love him. I was just spending a couple of days with Norm down in San Antonio. We had a good time. That dude is kind of a legend in the welding world without anybody knowing his name. Is pretty cool.
Mm-hmm.
It's pretty cool working with him. And then Todd was the same way. Todd was kind of a behind the scenes legend. No one ever knew who he was or what he looked like, but you certainly saw a lot of his work.
Oh yeah. Camera guy, man.
Yeah. Camera guy.
I got him on camera. I think one time when we were shooting a video at Weld.com.
I'm surprised you let that happen.
No, it worked out pretty good. But most people don't know who he is. And now he's doing like marketing and stuff with a different company because that was his background. Like, he didn't have a background in filming and editing. He taught himself all of that the whole time he was working at Weld.com.
Yeah, and he was
art shots, like the whole nine.
Good at it too.
Oh yeah, he's freaky good with it.
Yeah, when I went to film for Everlast, and he's like, "Oh, I'm gonna do an arc shot. Go ahead and start welding." And he was literally like 25 feet away from me with this camera. And I'm like, "You're really gonna get the arc shot from that far away?" And he's like, "Yep,
nuts, man." Yeah, he's smart with that shit. Good dude too. I like hanging out with Todd. And now he moved up to freaking PA. We did like a going away party. So me and him and Brian Legalio and we went to go shoot guns all day, and then right after that we went down to the Urban Still House. So the guys that make the Horse Soldier bourbon, they've got a restaurant over in St. Pete, which is where Todd was out of. And so that was like his last night we all got together and got to hang out and shit. So it was pretty cool.
Nice.
We haven't seen him since. We chat every once in a while on Instagram or LinkedIn, but yeah, he's off to bigger and better things now.
Yeah, he's a big hotshot marketing guy. Every now and then he'll grace me.
Fab Tech no more.
He'll grace me with his presence on a Call of Duty every now and then.
Oh, is he into that?
Oh yeah.
Oh geez.
Oh yeah, we have some good times.
I bet. Yeah, Todd's a good dude.
And that's kind of those unsung heroes of the industry that nobody knows or hears about. Like, if anybody really knew like Norm's background, that's he's kind of one of those dudes. And Todd, for sure, Todd's probably had more eyes on his work in the welding world than anybody else in the industry, and nobody knows who he is. Yep.
Definitely an unsung hero.
Yeah, for sure. I think, Todd's probably responsible for teaching more people how to weld than all of us combined. I mean, everybody combined.
That's no shit.
Right?
Yeah, because he's filmed all of us.
Yeah. No, that's a funny story there.
He's a hard man to track down now. He's super busy. He's doing all these marketing events and all that stuff.
Oh yeah, but he's Todd's awesome. That was I tell you what, for how small he was, you ever see that dude eat?
Oh yeah, he's got like a hollow leg or something.
Yeah, like we went out to of course Kansas City. You know, we're famous for barbecue, and he's like, we're eating barbecue. I was like, all right, that's fine. So I took him to a place, and he orders like a 4-person platter, and like just devour it. And he's like, dude, can we stop for ice cream? Like, what are you? Like, what are you?
You want some dessert?
Yeah, like, come on, man. Oh yeah.
Yeah, we could
good
definitely put
times.
it away.
That's good times there.
Well, gents, I'm sure everybody that's listening to the podcast knows where to find you, but if they don't, where can they track y'all down at? We'll go ahead and start with Mark.
My Instagram and Facebook is Winchester Metalworks.
And then, so you can find me. I'm Jesse Mccullum. You can find me on Instagram at mccullum.weldfab. Same for TikTok. Same for, Facebook. Mark and I are both admins on the Everlast Facebook pages. And then I guess we never really talked about it, but Mark and I also run tech support for Everlast. So if you got an Everlast machine and you've got a setup problem or a question or some kind of a technical issue, when you call in, you're talking to me and Mark.
No, that's great. I mean, they're going to get awesome customer support at that point. I just referred one of my buddies. He was having an issue, and I was like, yeah, it was. I think the day after I chatted with you, Mark, he called me up and was asking me. I was like, give Mark or Jesse a call. I was like, follow these two guys on Instagram and reach out to either one of them. And I said they'll get you squared away and taken care of.
I think there was a guy named Malachi that just hit me up. That was
yep. That was him.
Okay. Yeah, I talked to him about lasers the other day. Yeah, awesome.
Yep. Oh yeah, he's him and his business partner are looking to pick up a laser welder.
Yep. Yeah, I'm going to run some.
I guess they got a bunch of work.
I'm going to run some samples for him. I think early next week, and we're going to come to agreement.
Oh, dope.
Yeah, so that's awesome. I appreciate that.
Oh, anytime, man. Well, gents, as always, it's a pleasure chatting with you, and then I look forward to seeing y'all out in Orlando.
What do we have, like 170 days or something like that?
I should do a countdown. Yeah, something to that
effect. It's like 170 days till FabTech, so I look forward to it, man. It'll be good to see you guys down there. I look forward to always look forward to hanging out with Mark, but it'll be good to see you again, Becker.
You as well.
Yeah, you guys have a good one. Chat with you later.
All right, ladies and gents, I hope you all enjoyed the show. If you're finding these episodes beneficial to your welding journey, please leave me a review on Spotify or Apple Podcast, and consider sharing the episodes with a friend. You can also stream episodes directly from my website, arcjunkies.com, and feel free to hit me up with any questions, comments, or concerns by sending an email to show@arcjunkies.com. I hope you all have a great rest of your week. Stay safe out there, and until next time, make every weld better than your last.